So what we're going to do is we're going to talk about organic chemistry. So for today and for Monday, well, not Monday, Tuesday, we'll be talking about organic chemistry. And I'm just going to give you the basic introduction to it, not the nitty-gritty detail. Okay. Now, the thing is this, you will need organic chemistry or be familiar with some of it if you're planning to go into biology 12. Okay. And we'll be talking about that a little bit later on. So I have two handouts for you. You're welcome. All right. So what is organic chemistry? Now, if you look in the first bullet, it says the study of compounds that are mainly composed of carbon combined with other non-metal atoms. Now, you could think of it, organic chemistry, an easy way is the chemistry of dead things. Okay? In regards to majority of the materials that we use, let's say your plastic, your clothes, everything comes from plants or from petroleum products. Petroleum products is basically the decomposed remains of dinosaurs and plants from millions of years ago. So 90%, I would say a good 90% of all the material that we're wearing, that we have, is actually organic, is this organic chemistry. Because your clothes is made from cotton, which is from a plant. The plastic that you're drinking from your water bottles, the rubber silicone that you have for your foam protectors, those cases, those are probably a little bit of organic chemistry. Okay, plastic bags is organic chemistry. Okay, so basically, if we were to make it to bare bones definitions, it's carbon combined with other nonmetals such as oxygen, nitrogen, phosphorus, hydrogen, sulfur, whatever. Okay. A common one that most of you will probably be exposed to when you are now to even 19 is ethanol, alcohol, drinking alcohol. And if you notice, this is made up of carbon, hydrogen, oxygen, and another hydrogen. Okay. Now, I don't know if I will be able to get to this, but alcohol is technically a poison. So when you drink a lot of alcohol, what happens is people get cirrhosis of the liver or liver poisoning. And that's because the alcohol, this OH group, is a poison. And if you drink too much of it, your liver is trying to filter out that poison and you are overworking your liver. All right. This is why sometimes when you need to sterilize things, why do they put it in alcohol? Why do whenever you get your COVID shot, they put a little bit of rubbing alcohol on here. It's a poison to kill the bacteria. Okay. Now, when a compound is composed of only carbon and hydrogen, it's generally called a hydrocarbon. Now, this one, CH4, is methane. Now, where is methane commonly found? Does anybody know? Nope. Where is methane most commonly found or produced? Cow farts, that's right. Cow farts. This is the leading production of greenhouse gases, is the farming industry. They do produce a lot of methane gas. Okay, now, rumor has it, you hear about the myth where some people like they're, about to let go of a fart and they put a match and they try to create a bomb or something. Or I don't know if you've ever been into the washroom and somebody has just unloaded a number 2. They say, oh, light a match and put it in the toilet. It's supposed to dissipate the smell. Where does the smell come from? The methane gas. So that's where the idea of lighting a match after after you've done a number 2, you light a match, it's supposed to reduce the smell. And it's because it's reducing the amount of methane gas. Now, why is methane gas produced? We go into a little bit of biology. It is produced by the bacteria in your large intestines, by the E. coli. Okay. Now, for those of you that eat a lot of beans, do you notice that you fart a lot after you eat beans or something? And that's because the beans, the outer coating of the beans does not get digested in your stomach or in your small intestines very well. So you have a large food source for the E. coli bacteria in your large intestine to go at it. And this is why you produce a lot more bacteria. This is why you fart more, because it is a product of the bacteria in your gut. Okay. Now, the octane, this one is the basis for gasoline. Okay. Some of you are learning how to drive, and hopefully what happens is you are filling up your own gas. When you go to the gas station, you see it says 87, 89, 91 octane. What that is the percentage of this chemical in the gasoline. Okay. Most cars are run fine on 87 octane. But some high-end cars like a Lamborghini, a Ferrari, they need the pure stuff. Okay. And if you go to a gas station, let's say Chevron, what they do now is that they mix the octane with some alcohol. This is why you look on the gas stations at the pump, it says may contain 10% ethanol. So they mix this with this to sort of help your car burn a little bit more cheaply. Okay. Now, when the carbon atoms in a carbon compound cannot accommodate or bond to any more atoms, it is considered saturated. So what do I mean by this? So let's say, for example, I have a C, 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 C. Okay. So I have an H, 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 H. This would be considered saturated. Because all single bonds. So here, here, and here. So they are all considered saturated because there's only single bonds in carbon. Now, unsaturated would look something like this. This would be unsaturated. Because what you have is this thing double bond. So what happens is you have an extra bond that can be broken. Okay, so if it is saturated, You can think of it as all single bond. Okay, or if you break it, you cannot break any more bonds. Here is unsaturated. Now, where have you heard the term saturated and unsaturated before? Right, in fats. Okay, so what happens is, which is a good fat for you? Unsaturated fats. Now, if you Google saturated versus unsaturated fats, why is it a saturated fat? Because if you take a look at all of the carbon, there's only one bond or one line between each of them. Unsaturated fatty acid, notice that there is a double bond right here. There's two lines. We call that a double bond. Okay? Now, unsaturated fats are better for you because what happens is they do not promote the formation of bad cholesterol. There's good cholesterol and bad cholesterol. Good cholesterol comes from unsaturated fats, so things like vegetable oils, nuts, fish, avocado, eggs. Okay. Saturated fats come from processed meats like deli meats or steak, cheese, milk. Okay. The good stuff is bad for you. Now, the thing is this, it's okay to have meats and stuff, but you just don't want to have it, a lot of it all the time. You need to balance it. Okay. Now, unfortunately, some of you, like my daughter, this will kill her, this will kill her. So she can only eat, like, for unsaturated fats, would be like avocado. She doesn't like eggs, so avocado. All right. So anything that comes from been processed or comes from an animal is a source of saturated fatty acids, which is not good for you. This is the leading cause of high cholesterol, bad cholesterol. Okay. Now, some of you might say, Mr. Chan, butter is bad. So I don't eat butter, I eat margarine. Because margarine comes from vegetable oil. Better for me. Not necessarily. Margarine and anything that's been modified does not actually mean that it's better for you. When I was growing up around your age, it was like, oh, we're going to push margarine because margarine is healthier because it comes from vegetable oil. Now there's a big push now to go back to butter because butter is more natural. Even though it's a fatty acid, it's more of a natural food. Okay, so right now the health guidelines are going back and forth. But this is where you folks, when some of you are like, oh, saturated versus unsaturated fats, that's what it is. Okay, now, next day, I'm going to talk about trans fats. You will hear about trans fats, that's not good for you. So what is trans fats? And we'll talk about that next day. Okay. Now, there are three different ways of writing organic compounds. Okay. So let's say C3H8. The molecular formula is a C3H8. Okay. Now, what is the condensed structure? Would look something like this. It would be CH3, CH2, CH3, or in some books, you have H3C, CH2, CH3. Okay. Now, you might say, well, what is the difference between the two? Some people, when they write this, they think that hydrogen is joined with the carbon. So if you're looking on the left-hand side, some people might be confused with hydrogen being joined in. So in some books and in the worksheets I'll be giving you, what happens is that you have carbon. This indicates that carbon is attached to a carbon, which is attached to a carbon. So that is where the difference comes in. Okay. Both are correct. And the last one is the full structure or Lewis dot structure. So this one would look something like this. Oopsie. It would be C, H, 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 C, H, H, C, H, H, H. Now, in this case, Mr. Chan, how did you know you put 3 hydrogens around this carbon? How do you know you put 2 hydrogens on this carbon? How do you know you put 3 on the ending carbon? Goes back to charges. What's the charge on carbon when it joins with something? It's -4. But that magic number is 4. Carbon always wants 4 bonds. So in this case, since one carbon, this carbon has 1 bond, to fill the magic number of 4, it needs 1, 2, 3 more with hydrogen. This one, the middle one, why is there 2 hydrogens? Because for this carbon, there's 1 bond, there's another bond. To fill it in, hydrogen. Same thing. So in this case, you could put down here carbons want 4 bonds. So it always wants 4 bonds. Okay. Now, how do we recognize alkanes? Yeah. Now, there's some terminology, and this is probably where chemistry, for a lot of you, this is very similar to biology. A lot of vocabulary terms. Now, the term alkane, you recognize it by carbon atoms are attached by a single covalent bond. All the single bonds, all the single bonds, all the single bonds, all the single bonds. Enver, are you done with this? The dad jokes and the, yeah. Come on, man, 4 more days. Actually, 1 more day, and then you get traumatized and you go back to your home school, which is Burnaby North. What's your home school? Burnaby North. And then, you know, you see all your chemistry teachers, you're like, I miss Mr. Chan and his jokes. Not really. Okay. The general formula is CnH2n plus 2. Now, what do I mean by this? I could say, what is the formula of a 5-carbon alkane. Now, the key word is it is alkane. So alkanes all have a single bond. Now, there's 2 ways to do this. You can go this. 1, 2, 3, 4, 5. And then you add all your hydrogens. You can do that if you want. If you like to draw, go at it. You can do that. You have 5 carbons. Okay. So 5-carbon alkane, 5 carbons all in a single bond. Now, another way you could do it is you plug it into this formula. CnH2n. So you go, okay, C5H2 times 5 plus 2. So the formula is C5H12. Both ways work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can either draw it out this way or draw it this way. Both ways do it. Okay. Now, this class is probably, this first class is probably the most important for you to be aware of. Because if you can understand how to name alkanes and the rules, everything else is based upon this. Okay? So, when you're naming alkanes, okay, look, number 1, look for the longest continuous chain of carbon atoms. This determines the root name. Now, some of you probably did not bring your textbooks. The page 676 is talking about your textbook. So if you have it, great. If not, what I have is this package here for you. Now, if you take a look on page 676 in your textbook, or if you flip over to page 215 in the package that I gave you, what happens is they give you a list of the root names that you should be aware of. Okay? Or page 215. Now, so if you take a look on page 215 or page 676, it will give you the root name. Okay? Okay. So 1 carbon is methane. 2 carbons is ethane. 3 carbons is propane. This is the stuff for your barbecue. 4 carbons is butane. This is the stuff that you use in the, if you ever smoke, that's the stuff in the butane lighters, those little thick lighters. 5 is pentane, 6 is hexane, 7 is heptane, 8 is octane. Now, on page 215, they actually go 2 more. 9 is no name. Not no name. We're not talking about superstore. It's no name. 10 is decane, like decade. So a lot of the stuff is similar to your covalent naming. Okay? That you should memorize. I am not giving it to you. Okay? Now, look for carbon groups attached to the longest chain. When alkane groups appear as attached groups, they are named by dropping the ane and adding eel. Count the carbons in the longest chain to assign the attached group the lowest set of numbers, and the location and the name of each group are followed by the root alkane name. The groups are listed in alphabetical order, and the prefixes di, tri, or so on are used to list them. Now, some of you like going, yeah, need confusion. So how does it work? So hopefully I've given you enough space for maybe about 3 or 4 examples here, depending on how big you write. Okay, so what I'm going to do is, let's give you 4 examples. So let's break this down into 4 examples. Okay. All right. So let's say example number 1. Let's say I give you this one. CH3, CH2, CH3, CH, oopsie, not 3, CH, CH3, and let's say this is CH3. Okay. Now, when you write this down, first step, what is the longest chain? What's the longest continuous chain? 4. You cannot go backwards. It is not like Richmond driving where you just go any direction that you want. Oh, this is recorded. Sorry for those that live in Richmond. Okay. You can only go in one direction. Now, some of you might say, Mr. Chan, I go 1, 2, 3, 4. What if I go straight across? Good. How about if I go down? 1, 2, 3, then I turn right. Doesn't matter. You choose one direction and you stick with it. Whichever one is the longest chain. So here, if this is my longest chain, I have 4 carbons. So what's the root name for 4 carbons? Butane. That's right. So this will be, I'm just going to color code it butane. This looks like a big turd. Now, notice there's this little hanging on thingy. Okay. This is a 1 carbon. What is 1 carbon called when it is attached? Methyl. So here, this is methyl. Okay. So I've just done step 1 and I've done step 2. Step 1, I look for my longest chain. Step 2, I look for groups. Yeah? Now, step 3 is the confusing one. It says, count the carbons in the longest chain to assign the attached group the lowest set of numbers. Either go from left to right or right to left. So what do I mean by this? So in step number 3, you want to count the longest chain. Now you have 2 options. You can count from left to right. So this would be carbon 1, 2, 3, 4. Or you can count from right to left. 1, 2, 3, 4. Which direction will give this attached methyl group the smallest number? Going 1, 2, 3, 4, or 1, 2, 3, 4. Which direction? Right? Correct. The right to left. So in this case, the right to left gives the methyl the smallest number. So this is why it's called 2-methyl. Now, here is, again, I want to emphasize this. Why is this the most confusing? Is because of the fact that some people say, Mr. Chan, is there a difference in 2 and 3? The answer is no. It is just the direction in which you count. For example, to get to this classroom, you can go from the end of the lab and out the door, or you can come from out this door and then to the lab. Doesn't matter which way you go, you're still going to end up in this class. Okay, that's the same idea. Here, this is the same carbon. You're just numbering it 2 or 3. Does that make sense? Okay. All right. Now, let me give you another one here. So let's say we have this one. Okay. So let me use orange just to make it life easier. Okay. So let's go 2 here. Okay. So let's go carbon 2, 3. Now, I am not going to put the hydrogens in because this is a example, but when you're writing, you should put the hydrogens in. Okay. All right. First off, which is the longest chain? 7. Which direction? How do I get the 7 carbons? Okay, all right. Correct. You can go straight across. You can go down here, turn left, turn right. Yeah. Many different routes. There is no one right way. The key thing is you want to look for the longest chain. Okay? All right, so I'm going to mess you guys up and I'm going to use this one. Okay, Let's do it this way, just to make my life fun. This looks like your large intestine. Okay. 7 carbons. What's the root name? Heptane. This will be heptane. Okay. Now, step number 2, we look for our attached groups. So here, I have a single carbon, and I have this attached carbon. Hi.
So there's going to be cold bottled water by the office, and everyone needs it, okay? Because if you hydrate it,
We're all hot. We're all hot. Come on, we're 37.1 degrees Celsius. We're all hot.
water in this by the office.
Oh,
It's for emergency, bro.
okay. Oh, so nice. Okay. What's the single carbon again? So this one would be methyl. Two carbons. What's the 2 carbon called? Attached. It would be ethyl, right? So this will be ethyl. Do you know they used to, women's name which used to be called Ethel? There is a famous actress named Ethel Merman. This is in the 1950s, 60s, 40s, around that time. So some names get phased out over time. Ethel was one of them. And right now, I think Karen's will be eventually phased out for a little while. Okay. Yeah, you guys laugh. Okay. Now, here's where it's tricky now. Step number 3. You want the lowest set of numbers. So in this case, do you want to start? I'll draw it here. I'll go 1, 2, 3, 4, 5, 6, 7. Do you want to number it from left to right like that? Or do you want to go from 1, 2, 3, 4, 5, 6, 7? Which way gives you the smallest grouping of numbers? There's still 7 carbons. Correct. Left to right. Why, Jamie?
That's one right, first one, two, right, left, first one,
That's right. So here, it's either a 2 and a 5 or a 3 and a 6. So which ones give you the smaller number? We good with that? Okay. Now, so how do we name this? It says the location and the name are followed by the root name. The groups are listed in alphabetical order. So the key word here is alphabetical order. So you're not worried about the number, it's alphabetical order. So here it would be, let me write this down. It would be 5-ethyl to methyl heptane. Let's see, let me put a little, oopsie. Now, in some books, they use commas, I use dashes, doesn't matter. Okay. Two more examples, and then I'll call it a day. Okay, I can see Jackson going, yeah. This is the fun stuff. This is the longest class because once we get this done, everything else is basically those 4 steps. Okay. May I? Okay. So let's do number 3 here. Let's give you another one here. Okay. Okay. What's the longest chain? What is it? 8. That's right. I'm watching Jamie. He's like nodding with his head. 1, 2, 3, 4. All right. Correct. There's 8. So again, it's like this. So again, here, the root name would be octane. You okay, Amanda? Now, second step, let's look for my groups. So here I have this one. This is methyl. This one is methyl. And this one is ethyl. Okay. Standard first 2 steps. Now, which direction should we number from? Left to right or right to left? Left to right. Okay. So far, I've made that consistent. So here, you number this 1, 2, 3, 4, 5, 6, 7, 8. Now, how do we name this now? So here, this is how you would name it. 5-ethyl 2,2-dimethyl. That's what I wanted to talk to you about in 2 seconds. Okay. Now, Adam's first question. Did you fail English? Actually, I did. First year, I failed English, 45% in first year university. Failure is an option. Okay, it's okay to fail. It's called trying. So all of you will fail at least once. Yeah. Right? Don't try and fail. Well, that's okay. Failure is an option. You gotta learn from that. If there is no failure, there is no success. Okay. The first thing is this. Mr. Chan, D. Isn't that? But I'm looking for the name, not the prefix. So it's ethyl before methyl. I'm not worried what to do. Number two, notice I have two methyl groups. They're identical, so I have to use the prefix di. But notice, because they are attached to the same carbon, I have to acknowledge each one with a number. Okay? Every single group, even if it's the same number, has to have a number attached to it. So here, because I have two methyl groups attached to carbon number 2, 2,2-dimethyl basically means I have two methyl groups and they're both attached to the same carbon. The example would be like if you have a twin. Just because you have a twin doesn't mean when you go into a school system, you have to have your own pen number. You cannot share the same pen number as your twin. So here, each one of the groups has to have its own number. Make sense? Okay. All right. I'm going to give you an example. We've gone from formulas to names. Let's say if we can go do the other way. Okay. So what I'm going to do is I'm going to say, let me think. Okay. Let's say we have, okay. So we have 3-ethyl. 2-methyl. 4-propyl. Decane. Ethyl, 4-methyl. It's methyl, not menthol. Okay, it's not the stuff you smoke. Okay. Decane. Okay. So right now, I want you to try doing this. Okay. Try on your own. This is what you should have gotten. Okay. Decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can start from the left or the right, doesn't matter. 3-ethyl, so 1, 2, 3, there's an ethyl group. 2-methyl, 1, 2, there's a methyl group. 4-propyl. On carbon number 1, 2, 3, 4, you have your 2 carbon groups. Now, what are these little dashes? In this case, I'm just lazy. This represents hydrogen. On your test, I will be expecting you to draw the hydrogen. Okay? Remembering that the hydrogen is 4. Okay. All right. That is it for today's lesson. What I'm going to ask you to do right now is you look on the exercises on page 221. What I would like you to do is try numbers 8 and 9. Okay. Try numbers 8 and 9. Okay. The answers are on the back. No, just the note package I gave you. And the note package that I gave you, try numbers 8 and number 9, and the answers are on the back. Okay. Nope, that's fine. I just didn't draw it. All of them. Sure.
give you lots of practice.